Now we are done with almost all the basic terminologies related to current and electricity. We already know about the resistances and other external parameters that will affect any circuits. Let's try to understand the combination of more electrical resistances and electrical cells. In this particular video, I'll try to convey that what will happen if we have multiple resistances connected to any circuit and how we can calculate the equivalent of them. Let's try to understand it. Let me draw a very basic circuit with one cell and a one resistance. So, to make any resistance, we just have to draw a line zigzag. So, this will represent, let's say, R ohm resistance. To connect it with a battery, I just have to use some certain conductors and then I'll draw the battery. Let's say this battery has certain volt V. What it means? It means that this is the energy that this battery will gonna give to any electron that will pass through it. Means we know that there will be the electron flow from negative terminal to the positive terminal in this direction and the electrons will flow. Now again I am telling you, one should keep in mind that any electron or the current when flow through a resistance, the current will not vary, current will remain same. Means if a current is flowing through this resistance, its value will not gonna change, it will remain same. Means the number of charges going into the resistance will needs to be equal to the number of charges coming out. The only thing will change is the energy associated with the electrons. This is what gonna change. So electron will go through the resistance, it will lose some amount of energy and then it will again come and again gain the energy. And the current we define is directly opposite to the flow of this electron. Let's say the current is I. From the Ohm's law, we know we can directly write V equals to IR. Now, what will happen if we have multiple resistances? Let's try to understand. So, in order to connect multiple resistances, I have actually two choices. What are these choices? Either I can connect resistance in this way. Suppose this is one resistance, then I can add one more resistance, then I can add one more resistance. This is the one way of connecting a resistance and we call it a series combination. Like we can attach multiple resistances one after each other in a row. This is what we call a series combination. Apart from that, another possibility is that we can connect them in a parallel way like one below each other. I can connect them in this way and then connect all the points together with one positive terminal. Let's say this I can connect with a positive terminal and all the other points with a negative terminal. Now, let's start with the first series combination thing. This is what we call parallel combination. We'll understand the series combination first. So what I'll do in this same circuit, I'll try to attach more and more resistances in series to this R ohm resistance. Let's try. Now, if I have a circuit, so one resistance, let's say I have one more resistance. Let's start with 2 and then the same battery. Now, let's say the resistance of this is R1 ohm and this is R2 ohm. We are taking completely random values and this is a battery with EMF V. This is the EMF, electromotive force, is B. So this is the amount of energy V that this battery will transfer to any electron that will flow through it. Now, let's try to apply the Kirchhoff's current law in it. So for Kirchhoff's current law, I'll be letting again clockwise direction. CV, CW I'll write clockwise direction. We know the current will flow from this positive terminal to the negative terminal. This will be the direction of current. So, as I told you earlier, in the direction of current, if we'll move, think of an electron or a charge, you are moving in this direction. While going through a resistance in the direction of current, you will lose your energy. So, I'll be writing it as negative. So, I'm applying Kirchhoff's voltage law here actually, or the loop law. So, while moving from here, let's say this is A, B, C, D. A to B to C to D, A, B to C. I lose the energy, that is minus I am letting is the current, R1. This is the energy I'll lose. Again, you can see this is also in term of the voltage. So voltage is actually the energy. So IR1, then again I'll lose the energy, that is IR2. So I'll write it again in the negative way. One more thing that you should keep in mind, that the current in complete circuit will remain same as there are no multiple combinations. We have a single wire connecting all the elements. Thus the current will remain same. So IR1 plus IR2, and when I come to this voltage thing, what I'll get, so I'll write it in a plus way, plus V, and I'll write 0. So from this equation, I'll get V equals to IR1 plus IR2. We already know this, we already applied it. Now, what I can write this V? I can write this V as the multiplication of I from the Ohm's law that we already know. V equals to IR. But here R is nothing but R net. R net means the total resistance of this combination of circuits, means total resistance. Here I R1 and here we have, I forget I2, okay, I R2. Now, I can take I common and cancel it out from these terms. I'll get R net equals to R1 plus R2. Means when the resistance are in series like this, you can directly sum them out, R1 plus R2. Now, what if there are multiple N resistance? Let's try to understand. So, if there are multiple N resistance, suppose this is 1, this is 2, and we have up to N resistance. Again, the same circuit, we have one battery, and this is EMF V, and R1, R2, and up to Rn. Again, if we apply the Kirchhoff's voltage law, what I'll get? I'll get something like this. Let me write it equation. V equals to IR1 plus IR2. So we get V equals to, this V equals to IR1 plus IR2 up to IRN. We'll get this. Now, this V, again I can substitute as I multiplied by R net equals to, again the same thing, IR1 plus IR2 plus IRN. Cancelling out I, we'll again get R net equals to R1 plus R2 plus R3 up to Rn. Means it doesn't matter how much resistances you have. The net resistance will always come as the sum of all the values of individual resistance when they are connected in a series. So we are done with the series. This is what we are done. Now let's try to understand the mathematics of this parallel combination. Means when they are attached one down to each other. Let's see. So again, we'll start our discussion with drawing only two resistances. So I'll take again one circuit. Let's say this is one circuit. This is one circuit. And here I have two resistances. This is my one resistance. And here I'll attach one more resistance in parallel to it. Again, the values are like R1. And here we have R2. This is again V. Now, this time what one should keep in mind, that here we have to apply both KCL and KVL. Why? Because there will be three wires here. If I take this junction point, let's say A, B, C, D. Then at junction point A and B, actually there will be the splitting and the combining of the current. As at point A, when a current will move in this direction, let's say I current will move, it will break into two substituent current, that is I1 and I2. So what I can write I equals to I1 plus I2 following the KCL. I going in to this junction point A, and I1 and I2 are leaving the junction point A. So I equals to I1 and I2 I can write. Now from Ohm's law, what I can write? I equals to V by R. This I know from Ohm's law. So I can write this I is nothing, this V, as complete combination of the resistances is connected to this V. So V by R net I can write here, as I is nothing but the division of the net potential to the net resistance. I1, what I can write for I1? I can write V upon R1, and same I can write for I2, that is V upon R2. Now, why I have written V in place of both I1 and I2? Because if you will notice, all the resistance are connected to the same battery. There will be the same amount of loss or gain as they all are connected in parallel. Thus, we will get the value as V upon R net equals to V upon R1 plus V upon R2. Now again, cancelling this V, we will get 1 upon R net equals to 1 upon R1 plus 1 upon R2. So this is the value that we will get while the resistances are in parallel combination. Let's try to again put in resistances. So again, taking the same battery thing, same circuit, this is my battery, potential V. I have one resistance here, one more resistance here, let's say. Here I have one more resistance, and similarly, there are n resistances. All are parallel. All are parallel. So I am giving the values that say R1, R2, and up to Rn are there. Now, again, applying the same current law, here it says A, this is B, this is C, this is D. Again, at A, my current I, which is coming in, will get divided into multiple currents. How many currents? N. So I'll write I1 plus I2 up to In currents. Again, writing it in the same way, I is nothing but V, that is the battery, divided by R net equals to V by R1 plus V by R2 up to V by Rn. Now, what we can do? Similar thing. We just have to cancel out all the V as its value will remain same. So, we will get 1 upon R net equals to 1 upon R1 plus 1 upon R2 up to 1 upon Rn. So, it doesn't matter how much resistance you will add. If they are in series, you can directly add them. If they are in parallel, you have to add the reciprocal of them and you will get the reciprocal of the net resistance. Well, I hope you understood the combination of resistances. Now, let's try to understand it with a simple example. In this example, you can see that there are multiple resistances connected in a series as well as in a parallel combination. Before going through this question, I want you to concentrate on this point. Actually, what happens whenever we have any cell? Suppose I have a cell. This is a cell I am drawing. In practical world, what will happen if a cell's value or the electromotive force is given as 20 volt? In real life, it won't be able to give its 100%. Why? Because there are some chemical reactions going inside it. That chemical reaction will also generate some amount of heat that we call as an internal resistance. Internal resistance. Thus, every cell or a battery have certain amount of voltage written on it. That is actually the EMF when that cell is not connected to any circuit. But as soon as you connect it with any circuit and the current will start flow, it will try to generate some heat and certain potential drop will be there. That potential drop we can alter it by applying an internal resistance just next together the battery. This together will be called as a cell that is connected to any circuit. As you can see here, as battery is connected with a resistance, so that if current will flow, it will undergoes to a certain potential drop. Means it will not remain 20 volt. If there is a certain potential drop, it comes out to be the current flowing I into R. So if this is, let's say, 1 ohm or 2 ohm, then you will get 2 into I will be the potential drop. So total potential that this battery have is nothing but 20 minus 2I. So we have to convey or we have to keep these things in our mind while solving any circuit or a cell that have their own internal resistance. Let's start. So if I give the values again, A, this is point B, this is point C, this is point D, this is point E, this is point F. Now let's try to solve first B and C. Why? Because I can solve B and C and come up with a net resistance between B and C. Between the junction points, junction B and C, we have two resistance in parallel. That is 2 ohm and 2 ohm. So if I calculate their net resistance R between B and C, I'll get 1 upon 2 plus 1 upon 2. What it will be? It will be 1. So I'll get 1 upon RBC as 1 ohm. Thus I can write RBC is also nothing but 1 ohm. 1 ohm. So I can again substitute this. Let me substitute it. So I can substitute this whole thing between BC. This whole thing I can remove, and what I can put? I can put a single resistance. I can put a single resistance of 1 ohm. Now, again, if you notice, we have 1 ohm resistance, 1 ohm resistance, 1 ohm resistance, 1 ohm resistance. Means we have 4 resistance in a series. How? If I move in this direction, I'll go through this 1 ohm, I'll go through this 1 ohm, I'll go through this 1 ohm, and I'll go through this ohm. Every resistance will give me a certain potential drop, and from 20 volt, I'll eventually again get to 0 volts. Now, I have 4 resistances. Let's say between battery, I have 4 resistances, each of 1 ohm, and in series combination, in series. So what I can write, I can simply write R net comes out to be 1 plus 1 plus 1 plus 1. So we'll get 4 ohm as a net resistance of this complete circuit. Now, we can calculate the current easily from Ohm's law. What we know from Ohm's law, what we know? We know V equals to IR. So I will be nothing but V by R. Here, this 1 ohm was actually the internal resistance of this 20 volt battery, and we corrected it while taking is at a normal resistance. So we get I equals to V by R. V is nothing but 20, and net ohm resistance that we'll get is 4. So we'll get I as 5 ampere. Well, that's all for this video. I hope you understood how to solve the equation for calculating the net resistance when they are combined together in a circuit. You have seen that there are only two possibilities, either resistance are in parallel or series combinations. In the next video, we will understand the combination of cells. Till then, stay connected with Tutorac and explore more about current electricity.